Hello guys, welcome to our class. Good day to you. Good morning, good afternoon, good evening, depending on the location that you are watching this video from. This is Normal Science Tutors Online, and in this particular channel, what we are doing here is that we are bringing physics lectures direct to your very doorstep. Okay, and so far we have treated a lot of topics that are covered in the Nigerian curriculum of physics. All right, so for in this particular video or in this particular lecture, we'll be looking at electric field. We discuss electric force and Coulomb's law of electricity. So now we are going to be looking at electric field. Okay, so please guys, get your writing materials ready. Get your biros, your calculators, your writing pad, so that we can go straight to our class for today. But before then, if you have not subscribed to the channel, please subscribe to the channel and click on the notification bell, and YouTube will notify you when we upload a new video. Give us a like, give us a thumbs up, help us to share the video in your various social media platforms. Is that okay? You can also reach us via the WhatsApp number that is showing right on your screen. Right, so I remain Otubo Michael, and we are going straight to our class for today. Okay, so today we are looking at electric field, and then we also look at some calculations after we dwell on the equations for electric field, and we'll do some calculations to drive home what we have discussed. So we'll look at electric field and the electric field between 2 point charges that are separated by a distance. All right, so guys, let's go for the class for today. Electric fields. So what is an electric field and what is electric field intensity? So an electric field can be defined as a region where an electric force is experienced by a charged body, and this electric field is represented by electric lines of force. Please, we have already discussed electric lines of force in our previous video, and that's why I said go back and view that video that we discussed before. The video is titled Electric Field and Their Properties. So just go to that video, Electric Field and Their Properties. You will see how the lines of force are represented on a point charge in an electric field. Okay, so if you look at that video, you will see that the lines of force, they radiate out of a positive point charge, while they radiate inward around a negative point charge. Okay, so I want you to go back to that video and get a clearer understanding on that. So electric lines of force are imaginary lines drawn in such a way that the direction of any point is the same as the direction of the field at that point. Okay, so this is what I just mentioned, and go back to that video that is titled Electric Field and Their Properties. Electric field and their properties. So if you go to that video, you get a clearer understanding on how to draw the lines of force for a point charge that is in an electric field. Okay, so having that said, electric field intensity or strength of an electric field at any point is defined as the force per unit positive charge at that point. So what that simply means that electric field or electric field intensity E is given by force per unit charge, F over Q. Okay, and the unit is Newton Coulomb. Force is Newton now, and charge is Coulomb. So the unit is Newton Coulomb. Now this equation can also be written as force is equals to what? Electric field intensity times the unit charge. Okay, so electric force equals to electric charge multiplied by electric field intensity. All right, but remember that the electric field intensity due to a point charge Q at a distance arrow is given by the electric force divided by the point charge. Okay, electric charge divided by the point charge. So remember that the electric force is equals to force is equals to the product of the charge divided by the square of the distance apart, or multiplied by the constants. Okay, so if I remove this 4 pi epsilon 0, I can write this as F. Since you already know the value of that, you can write that K, F is equals to K, Q1, Q2, all over arrow squared. Okay, so for a point charge in an electric field, we can write this. We know that for work done, or we know that E, which is the electric field density, is equals to this force all over Q. So what you do is substitute the value for the force into this particular equation. So you will have this. So this, for this one cancels out, this cancels out. So what you come up with is this particular equation. So electric field intensity is equals to the charge all over the square of the distance apart. Okay, so if we take this 1 all over 4 pi epsilon 0 to be K, the equation can be written simply as this. Okay, equation can be written simply as that. So this equation gives you the electric field intensity due to a charge Q at a distance r from the charge. All right, so this is the equation for the electric field intensity for a point charge that's at a distance from the charge. So with this equation, please take note of this equation. Okay, take note of this equation too. Know that electric field intensity equals to force all over charge, and that force equals to electric charge times electric field intensity. Then from there, we're able to derive this particular equation. So with this equation, you can solve any problem on electric field intensity. So right away, let's go and then solve some problems. Okay, so this question says that calculate the electric field intensity in a vacuum at a distance of 10 centimeters from a charge of 5 times 10⁻⁶, 5 times 10⁻⁻⁴ coulomb. Take 1 all over 4 pi epsilon 0 to be equals to 9.0 times 10⁻⁹ meters square per coulomb square. Okay, so from our discussion now, we just find out that E, electric field intensity, is equals to KQ all over r squared. Okay, so we know that K is equals to this. Okay, so K here is equals to 1 all over 4 pi epsilon 0, and which is going to be 9.0 times 10 to the power 9 Newton meters squared per coulomb squared. Okay, it's 9. Right, so your charge is given to you to be 5 times 10 to the power -4 coulomb, and then the distance is given to you to be 10 centimeters. So having gotten all this, you can now go straight to solve your problems, or to solve your problem. Okay, So substitute into this particular equation. You have that E is equals to 9.0 times 10 raised to power 9, okay, multiplied by the charge 5 times 10 raised to power minus 4, or divide by what? 0.1 raised to power 2. So by the time you work this out with your calculator, you will have that the electric field intensity is equal to 4.5 times 10 raised to power 8 Newton per coulomb. Okay, so this is just a practical application of this equation that we just derived. I hope this is simple and it's pretty easy for you to follow through. Let's go and solve another problem. So this question says that 2-point charges of magnitude plus 20 times 10 raised to the power minus 8 coulomb and minus 5 times 10 raised to the power minus 8 coulomb are separated by a distance of 10 centimeters in vacuum as shown in diagram below. Calculate the electric field intensity at a point P, midway between the charges, and then the force on a minus 4 times 10 to the power minus 8 coulomb charge at a point P. At point P, take your constant of proportionality to be 9.0 times 10 to the power 9 Newton meter square per coulomb square. This is a NECO examination question. Okay, so guys, how do you go about this? First of all, we are told that the 2-point charges are separated by a distance of 10 centimeters and the point P is midway between them. So the distance of each of the charge from point P will be equal to what? 5 centimeters. Okay, so 5 centimeters. This will also be 5 centimeters, totaling 10 centimeters. So you know you have to convert centimeters to meters. Alright, so what you are now going to do is that you are going to calculate each of the electric field intensity for each of these charges relating to point P. Okay, so the electric field at point P due to Q1. So if this is Q1, let's take this as Q1. Okay, then this is Q2. Okay, so the electric field at point P due to Q1, okay, is equals to EP at point P due to Q1 is equals to K Q1 all over R squared. Remember that K is your constant of proportionality here, so just put that value there. You have 9.0 times 10 raised to power 9 multiplied by the value of your charge 20 times 10 raised to power minus 8, all divided by the distance to P. Okay, so you have 0.05 raised to power 2. Okay, so by the time you work that out, you will have that the value of the electric field intensity there at point P due to first charge Q1 is equal to 7.2 times 10 raised to power 5 coulomb, 5 Newton coulomb. Then the value of this due to Q2, we'll now do that for Q2 too, because at the end of the day you are going to find the resultant of the electric field intensity at P. That's what you use to get the electric field intensity at P. So you find the resultant electric field intensity. So electric field intensity at P due to Q2 will be equals to, so can we take this as E1 and take this as E2. Okay, so the same thing that we did for Q1, Q2 all over R squared. So you do that 9.0 times 10 raised to the power 9 multiplied by 5 times 10 raised to the power minus 8 coulomb, all divided by 0.05 raised to the power 2. Okay, so if you work that out, you are going to have 1.8 times 10 raised to the power 5 Newton coulomb. So the resultant electric field at P, resultant E at P is what you are looking for at P, is equals to E1 plus E2. Okay, so when you add these two together, it will give you 7.2 times 10 raised to the power 5 plus 1.8 times 10 raised to the power 5. So this gives you what? That gives you, just add the two together. So if you add these two, you have 9.0 times 10 raised to the power 5 Newton coulomb. So this is the resultant electric field intensity at point P, midway between the charges. So this is how to find resultant electric field. Now, having gotten this, the second question is that you should find the force on A minus 4 times 10 to the power minus this charge at that point. Now we know that electric field intensity, that is in equation number 2. This is number 1. Okay, so we know that electric field intensity is equals to force over charge. Therefore, the force is equals to electric field intensity times the charge. Okay, so from our calculation, we have already gotten the electric field intensity for this particular problem. So what you now do is substitute into that. We have 9.0 multiplied by 10 raised to the power minus 5 times 4 times 10 raised to the power minus 8. Okay, so by the time you work this out, you are going to have 3.6. Okay, 4 times 9 is 36, so you are going to have 3.6 times 10 raised to the power minus 2 Newton. Alright guys, so that is it. So if you look at this question, you see the process and how we are able to resolve the resultant electric field intensity, and now we are able to use that electric field intensity to find the force on this particular charge in the same field. Okay, so this is how to solve some problems in this particular topic. I hope this is clear and you understood what we have discussed so far. All right. Okay, so this is your test your understanding page. The first question says, in a uniform electric field, the magnitude of the force on a charge of 0.2 coulomb is 4 Newton. Calculate the electric field intensity. This is very simple. Then a charge of 1.6 times 0.8 coulomb is placed in a uniform electric field of intensity this. Okay, so this is a charge. This is your electric field intensity. They say what is the magnitude of the electric field is acting on the charge. Very simple. Okay, so guys, please go through these questions and solve them, and then try your answer on some other past questions. Okay, so that you can get a better and clearer understanding, a deeper understanding. Because in physics, the more questions you solve, the more understanding that you will get. Physics has very little theory. Everything about physics is calculations, applications of principles. So you need to understand the principles and then know which formula to use to solve any problems that you have. And you should be able to relate these principles to everyday life. Okay, so this is where we are drawing the curtain for our class today. But before I leave, please, if you have not subscribed to our channel, please subscribe to the channel, give us a like, give us a thumbs up, give us positive comments. Is that okay? So when we upload a new video, YouTube will notify you, right? Give us thumbs up, give us positive comments. Thank you so much. We appreciate you for your time. Thank you for visiting our channel. Please help us to share our videos on your various social media platforms. Inform your friends, invite your friends to come and enjoy what you are enjoying in YouTube. Okay, you can also reach us via the WhatsApp number that is showing right on your screen. Reach us through that number. If you have any challenge, we'll be able to help you out. Okay, so thanks a lot, and we hope to see you in our next class.